Hello, good morning. This is Teacher Kindle, and today we will solve some related problems regarding series and parallel connection. But before that, let's first learn about the Ohm's law, which formula is designated as V is equals to IR, wherein the current is directly proportional to its voltage. So let us recall voltage known as volts. Okay, the unit of it is V, then the current, which is this one, the I, that is in terms of amperes, or A. Then the resistance, this one, the resistance. So that is known as ohms or, okay, that unit. Alright, in series connection, okay, the total resistance is known to be the summation of R1 plus R2 plus R3 plus, okay, Rn, so on and so forth. And to solve for its total current, okay, so the total current is just equal to the current for the resistor 1, okay, then, no, this is equal, okay. So that is just equal also to I2, then equal to I3, so on. And for the total voltage, okay, that is just V1 plus V2 plus V3 plus so on and so forth. Okay, so let's take for example this one. Okay, we have a sample circuit here. Okay, we have resistor. We have three resistors connected. This loop, so we have here the source as 12 volts, then positive and the negative. Okay, the longer line, this one, that is where the positive is, okay, designated as positive, and the shorter line is the negative one. Okay, so we have here R1, R2, and R3. Let's say this is 10 ohms, this is 20 ohms, and this is 30 ohms. Okay, now okay, we solve for RT. Based on the formula, okay, to solve for RT, let's just add the three resistors. So 10 ohms plus 20 ohms plus 30 ohms, correct. Okay, so the total resistance is 60 ohms. Okay, so now we solve for the IT. So recalling about the Ohm's law, okay, V is equals to IR. So we could also say that the I is equals to V over R, right? So we get the value of IT by dividing the total voltage over the total resistance, which is the total voltage is 12 volts and the resistance, total resistance is 60 ohms. Okay, so what's the answer for that? Okay, you divide 12 divided by 60. Yes, that is 0.2 amperes. Okay, so now we already have the value for IT, and we all know that IT is equals to I1 is equals to I2 and equals to I3, right? In series connection. And now we solve for the voltage, okay? For the voltage for the first resistor. So it is just I1 times R1. So the I1 is 0.2 amperes times the resistance 10 ohms. Okay, so what is that? Okay, that is equals to 2 volts. Now we solve for the V2. Okay, that's just I2 times R2, 0.2 amperes times the resistance for the second resistor, and we will get times 20, 4 volts. Okay, so for the V3, solve for V3. Okay, that is just I3 times R3, 0.2 amperes times 30 ohms. So we will get 6 volts. Alright, so that's how we will get the total current, the total resistance, and the voltage drop of each resistors in a series connection. So if we will add up the V1, V2, and V3, okay, so V1 plus V2 plus V3, we will get 12 volts.